Possibly. See where we get material-wise.
4 cannot do that, though, Jason.
I don't know. It seems like we're off to a slow start.
2 right there.
So you get our test back from now then?
It can't be.
Oh no. I'm basically saying it'll be your reward for doing the right thing. Right. All right. So looking at numbers 1 and 2, what's the obvious thing that you notice?
Fraction.
All right, I heard fraction. Okay, what does fraction tell us?
It's going to get wider.
It's going to get wider. All right, so we're looking for a wide parabola. All right, now that's bringing us to C and D basically. How do we know it's D?
One to -2. Oh, yeah.
The negative 2 wide. That's good. I'll take it.
Wider than.
So 2 is D. All right. Another way you could have told that 2 is D is that. Yeah, it's a fractional coefficient, sure, but what kind of number is that? Positive or negative? Positive. And what does a positive coefficient tell you? Minimum vertex, aka the parabola opens upward. Right? So if you're limited between choices C and D for that particular question, then you would know it'd have to be D because that's the one that opens upwards. All right. We have another fractional one, number 3. Which one would that correspond to? C. All right. So let's go back to the non-fractional ones. It should pretty much answer itself now. Number 1 has to be what?
B.
B. Why?
Because it's a -2.
Because it's a -2 as your y-intercept. All right, so we can take that. Perfect. It also opens up, so that's confirming what you already knew. All right, so if you decided that it was B because it had a -2 as a y-intercept, then you just confirmed that fact by saying, okay, and it also is supposed to open upward, and that's what happened here. And A would have to be number 4. All right, and you can see in that case, just by evaluating it, not actually substituting, but just by looking at it, I have a +2, that's my y-intercept, check. Negative leading coefficient, opening downward. A number bigger than 1, if I'm looking at absolute value of the -2, it's 2, which is a number bigger than 1, it's telling me that my parabola should be skinnier. So that's your indicator. Yeah. So let's say you had no idea about any of that stuff. Well, let's say I completely forgot to teach all this material, and you walked into the Regents exam and there was a question like this. How could you get this right?
Calculator. Wow, cheap on me.
Calculator, exactly. Type it into your calculator and look at the picture. All right? If the picture doesn't tell you everything you need to know, go to the table and look for some points. All right? So it begs the question, do you really need to know all these facts to get a question right on the Regents exam? Of course not. Is it important to know all these facts moving forward? Yes, definitely. Otherwise, we wouldn't be teaching it. All right? So that, there's meaning to all this stuff, but like a lot of the concepts in this course, you can get stuff right on the exam without really doing much work. That's the benefit of having multiple choice questions. But as you move forward, because this is really, between this and geometry, this is really the only courses that require an exam at the end of the year. After that, I don't know too many teachers who, in math anyway, that do a lot of multiple choice. It's almost all free response, show your work kind of stuff, right? Try to avoid the guessing aspect of it. Unless you go to an AP, AP goes back to multiple choice and free response. So it's 5 choices, yeah. And for AP exams, it's those are the worst kind of multiple choice questions because those are the ones that are really designed to trick you. These are, they put a trick in there, but they're supposed to be the obvious trick. Like on the last quiz where I put the axis of symmetry question. X equals 1, X equals -1, and then I put Y equals 1, Y equals -1. You should have eliminated those 2 bad boys right off the bat. The Y equals, because that's not how axis of symmetry works. That was like an obvious trick. Like a student looking at that question is like, I'm not falling into that trap. All right? So, anyway, quadratic transformations. All right. Just got to take note of something. One day we'll figure it out. Write the quadratic, write the function, and it's going to be quadratic, that defines the described transformation of the graph of the quadratic parent function f of x equals x squared. All right? So parent function of any kind of graph, any model, is basically the stripped down version of whatever the equation is. Right? So in the case of a quadratic, it's just y equals x squared. If we were talking about a linear function, it would just be y equals x. Right? It's the most basic form of any type of function. Right? So what's the benefit of it? It's a basis for comparison. If we see how each graph relates to y equals x squared, then we can determine what the characteristics are. Now, the standard form, also known as the vertex form, as you know, we spent some time working with this, is a times x minus h squared plus k. We talked about it yesterday. I wrote it up on this board. I was comparing that to the other form, the y equals ax squared plus bx plus c. And I pointed out all the similarities and differences. And we basically settled on to the idea, whether you believe me or not, that this is the better version of a quadratic. It tells you more stuff. All right? You can't place a quadratic on a graph without knowing where its vertex is. This tells you the vertex directly. The other one makes you figure out what the vertex is. All right? We're going to do an activity next week where you're going to discover how this equation gives you the vertex. It's actually pretty cool. Right? I know that because I created it myself. So what we want to do is create a function that is going to have the following characteristics. So 3 unit shifts to the right. So when in doubt, grab your calculator, take a guess. You know, you probably have some semblance of an idea as to where that 3 should go in your equation. But, you know, it's possible you guessed wrong. Or maybe you thought you knew something and it was incorrect. Your calculator's your backup plan. All right? So just as a quick review, the A represents the stretch or shrink. That does not start with the letter T. Fun fact. Stretch, shrink. The H and K, yeah, they're the vertex. But if the vertex normally would be at 0, 0, H is actually the horizontal movement of the vertex. So H is a horizontal shift. And K is the vertical shift. The other class came up with that. Misspelling vertical, so it has a K in it, so it jives with the K. I liked it, so I'm going with it. Yeah, because the rationale is like you can't use V to represent vertical shift because V is already representing vertex. So they use K, but like it just doesn't seem reasonable. So they're like, yeah, just change the C to a K. I'm like, I'm all about that. Let's go. So with that information, can you tell me what the equation would be that would represent 3 unit shifts to the right? H would end up being negative. So when we put it in the equation, that's the only thing that's changing. So if I look at, and I'm just going to kind of tuck it in here, extreme close-up. So this equation in full-blown standard form would be f of x is equal to 1 times x minus 0 squared plus 0. All right, that seems like a really unnecessary step. Like, why would I ever write it that way? It's just to really illustrate the idea that the vertical stretch is a factor of 1. Right? So it's 1 times whatever a standard parabola would look like. The H and K values are 0, 0, putting our vertex at the origin, but more importantly, it's telling us that there is no shift vertically or horizontally from the ordinary vertex. All right. So what this is telling me is that if I want to go 3 unit shifts to the right, the only thing I have to manipulate is the H value. So the a value is going to stay put. The h value is going to become a 3, making the binomial x minus 3. And we're not shifting upward at all, or downward. Now you can cut to the chase here and just write it as y equals x minus 3 squared. But I don't think you fully understand why this answer is what it is without understanding where it came from. All right. So now, a vertical shrink by a factor of 1/2. That's still going back to the parent function. It's not a continuation of part A. All right. So if I'm looking at that, the only thing I'm going to manipulate in my original function would be the a value, 1/2 x minus 0 squared plus 0, which again simplifies right on down to just y equals 1/2 x squared. All right, so again, you can jump right to the final answer if you want, but there you should at least consider why you're getting the final answer that you are. All right. Reflection over the x-axis. Okay, so a reflection over the x-axis, that's kind of a weird thing to think about. But if you consider it just in ordinary terms, we want it to open downward. Because the original parabola is opening upward. So I want the same parabola, but I want it to open downward. All right, so the only thing I need to manipulate would be my a value. All right, so instead of it being a positive 1, what would I make it? A negative 1. Everything else stays the same. Bless you. Yeah, he gets his money's worth. But that's the thing, you never hear him sneeze more than once. Like in any given day. It's always just one and done. Yeah. Blow the windows out. Just get it done with all in the shot. I always imagine that right before he sneezes, he's like, dang, I think I'm sick. And then he sneezes, and he's like, oh, all better. And just get it all out. All right, 4 unit shifts up. So the only thing that's going to change here would be what? The k. So everything else is going to remain the same, RTS. Y equals x squared plus 4. All right, every one of these things could be checked on your calculator. Okay. Now, do you want to? I mean, hopefully you have a little bit of faith that you understand the rules, but like day of the Regents exam, you don't want to throw away points, right? So you got plenty of time. And I'll tell you, I'll mention this more as we get closer to the exam, but you have 3 hours to do an exam that it's going to take most of you like about an hour to do. And you're required to stay there for half the time, so an hour and a half. So in most cases, you're going to have a half an hour with like nothing to do. So that half an hour could be spent going through every one of your answers and checking them all on your calculator. All right, it's good use of your time. Now, in reality, that might only take you 5 minutes, in which case you still have 25 minutes to kill. So what most people do is they try to go to the bathroom 7 or 8 times, but you're only going to be able to do that once. So and that'll take you like 2 minutes, I mean. And so in the end, you're still going to have a lot of time to just sit there and think about life. Instead of doing that, we're like, how did I get to this moment? Like, where did it all go wrong? Instead of that, you could be in a position where you're like, all right, I'll just check it again. and again, and again, and again. Because the worst thing ever is getting that phone call saying, yeah, you got to come back into school to trace over everything in pen because you wrote everything in pencil and you didn't follow instructions. You're like, dang, I was sitting there for 30 minutes doing nothing. I could have been doing that the whole time. So just when you thought you were on summer break, you're not. Right? So just things to consider. So check your work repeatedly. And I'm going to come around to you during the exam because I'm not allowed to be in the room to actually administer the exam, but I can come in to check on you. The only thing I'm going to go around and say, I'm not going to ask how you're feeling. I'm not going to ask you if you have any questions on any problems, nothing like that. I'm going to say, did you check your work? You'll say, yeah. I'll say, check it again. And then I'll move on to the next person. Did you check your work? Yeah? Check it again. And I'm going to say that about 50 times because I have 50 students taking the exam. So, and then I might even say it to some other teacher students just to end with a nice round number. So, yeah, it's that important. All right. Anyway, I'm going to tuck in a number 5 here. Number 5, part E. Do all at once. Oh, geez, I don't know why I opted to go script here. That's just a bad choice. All right. So what I mean by that is, let's do all of this stuff in one shot and create a mega equation. So I want something that's 3 units shifted to the right, a vertical shrink factor of 1/2, a reflection over the x-axis, and also a 4-unit shift up.
So it's negative 1/2 x minus 3 squared is 1.
Indeed.
Wow, Jason.
Well, this all right. So A through D are your itemized, and E is the new problem where you put it all together. And I'll take that as a typo from somebody. I think Atticus is maxed out too.
Am I maxed out?
But that's good news.
Am I maxed out? I think I sent you like 20 in one day. Wait, have I got any points?
I think you might have more that you can do. I think you're maxed out.
Better safe than sorry.
Better safe than sorry, yeah, totally. I think you might be you might be at 2, but you might also be maxed. Yeah. Any way that gets the information to me is fine.
So much better than typing it all out.
Yeah. All right. So let's do number 2 together, and then I'll let you do the rest on your own. Describe all the transformations of the quadratic parent function x squared, y equals x squared, that results in each quadratic function. And you notice how I'm saying y equals instead of f of x? Because they're interchangeable. F of x means it's the function of x, means it passes the vertical line test. We learned about that in Unit 4. But it's really just talking about an equation, y equals. Why do I say y equals? Because f of x has more syllables. All right, so I say y equals because it's more convenient for me. And it should be something that you become fluent with, where you see f of x and you automatically think y equals, and you see y equals, and if it's a function, you automatically think f of x. All right, so in A, what do we have going on here? Opens up, shifts left by 4 units. What else? Shifts down 1 unit. One thing we're missing. Stretch factor. Factor of 2. All right. So very importantly, you have the word factor in there, because factor implies multiplication. When you factor a polynomial, you're writing it as a product of 2 expressions. You're writing it as a multiplication problem. All right. So that term factor, like, here's an example. SPF. Do you know what SPF stands for? One sec.
Sun protection.
Sun protection.
Fun.
Jeez. Factor, yeah, kind of like what we're talking about. Now, what do you think it means?
The amount that the sun protects.
The amount that the sun protects you. Okay, that's...
I meant the
Sunscreen.
Yeah, because the sun totally protects everyone. The amount of protection given by the lotion to protect you from the sun?
Yeah.
All right, so how do we measure that? Does anybody know?
SPF.
What do you think is the role that the word factor plays in that term?
How much is that like gonna?
Well, what is another name for factor? Well, considering I just said it, we should have a multiplication. It's talking about multiplication. It's a multiplier, all right? And so think of it this way. If you have SPF 30, that is 30 times, and so that lotion is going to provide you with 30 times the amount of protection that your skin would ordinarily give you from the sun. All right? So if you think of it this way, like I have relatively fair skin, I might burn in 10 minutes, right, under a strong sun. All right, so like high noon, I'll get roasted in like 20 minutes, but I'll start to get a sunburn in 5 to 10 minutes. SPF 30 will take that amount of time and multiply it by 30, and that's the amount of protection I have. All right, so it is a multiplier related to some unknown quantity, and it's variable. All right, variable is algebra. All right, so it differs from person to person. If you have skin that's more resistant to the sun, then that SPF 30 might protect you for a longer period of time. All right, so what we're talking about here is a factor of 2. So if a parabola would ordinarily have, let's say, a y value of 1 when you move out 1 unit away from the vertex, the factor of 2, the stretch factor of 2, is going to give you a y value double that. All right, so it'll give you measures that are twice what you would expect from your parent function y equals x squared from. Sorry, I saw a license plate yesterday on a Tesla that said Frunky. I thought it was hilarious, but it wasn't as hilarious as Professor. I sent him the picture, and he was like, "Loser." It's the greatest moment in my life, which is really sad. Anyway, what's going on with B?
Wait, how do you know if it's open like upward and downward?
Well, that's what I'm going to get to in B.
It's open downward.
Opens downward. How do you know?
So it's a negative.
Exactamundo. So you already know it. Is that a? Oh, okay.
What does open up and down mean?
Could somebody else explain that to Henry? Kai, what do you got there?
It's like whether the vertex is a maximum or a minimum. So it's like a maximum that opens down.
Yeah. All right. So what about the shift?
It's going 1 to the right.
Shifts 1 to the right. And up 3 units up. All right. We addressed opening downward. What about a stretch factor or a shrink factor? Well, we got the negative. That's taken care of when we say downward. So if we're talking about, so our shrink factor or stretch factor would be 1, right? Because we disregard the negative sign. Is that changing the size of the parabola? Or the shape of it? What happens when you multiply something by the number 1? It stays exactly the same. So we have no stretch or shrink. All right. Very important that you address all of those pieces of information when you're evaluating a transformation. Right? You got to talk about orientation, up or down. You have to talk about translations, which means left or right, up or down, if it's shifting. And you also have to address the stretch or shrink. If it is being stretched or shrunk, you would very easily be able to note that. But If there is no stretch or shrink, you actually have to state that also. If you don't, you're losing credit. All right, so you got to be careful about that. All right, you have to evaluate all parts of the graph. All right, part C, what's going on? Opens downward. All right, it shifts. So we might say 4 to the right, but usually the left-right is the part that's in parentheses associated with the x. No parentheses, so no horizontal shift. So shifts only 4 units. What are we saying? Down. All right, I put the word only in there. All right, that's important because I'm addressing the fact that it's not shifting left or right. If you don't want to put the word only in there, that's fine, but you then have to say that it's shifting 0 units left or right. I wouldn't want to write that. If I write only, I'm saying, it's implied anyway, it's enough information to say that the only shift that's happening is in the downward direction. All right? I have indirectly addressed the fact that it's not going left or right. All right, so very important. Okay, in terms of stretch and shrink, what do we got?
Next chapter of 1 to
All right, is it a stretch? Shrink.
rewind your phone, Henry.
No, this is a ring phone.
You're welcome, bud. Have a good weekend. All right, so